Have you ever wondered if your database transactions are truly safe from unexpected changes, even when you think you have strong protection in place? It is a critical question for ensuring data integrity and reliable application behavior in any system managing persistent data. Yes, the repeatable read isolation level can indeed experience phantom reads. While this powerful isolation level prevents one type of data inconsistency, it does not inherently guarantee protection against all anomalies. Understanding this specific nuance is absolutely crucial for architects and developers building robust and highly consistent database systems. The core mechanism behind repeatable read is its ironclad guarantee that any rows you read once during a transaction will return the exact same values if you read them again within that same transaction. This consistency is typically achieved by placing shared locks on the specific rows retrieved by your initial queries. These shared locks act as a safeguard, preventing other concurrent transactions from modifying or deleting those exact rows. This mechanism effectively eliminates common issues like non-repeatable reads, where a row's value might change between reads and lost updates, where one transaction's changes are overridden by another. However, the phenomenon of phantom reads arises when another transaction inserts new rows that happen to satisfy the conditions of your prior query. Since repeatable read traditionally focuses its locking efforts on the existing rows that were part of your original read set, it does not inherently prevent new rows from being added to the underlying table or index. If you were to execute the identical query again within the same transaction, these newly inserted rows would suddenly appear in your result set as unexpected phantoms, even though the original rows you selected have remained completely unchanged. It is a subtle but significant distinction between preventing changes to existing data and preventing the appearance of new data. To fully guard against phantom reads, especially in scenarios demanding the utmost data consistency, you generally need to employ the serializable isolation level. This highest isolation level prevents all three main types of transaction anomalies: dirty reads, non-repeatable reads, and phantom reads. It achieves this comprehensive protection by implementing much stricter locking policies, often locking not just the specific rows but entire ranges of data, or even, in some cases, the entire table, depending on the specific database system and the nature of the query. This level ensures that your transaction operates as if it is the sole transaction running in the system. Interestingly, some sophisticated database implementations, such as PostgreSQL and MySQL with its InnoDB engine, offer specific features within their repeatable read implementation that can prevent phantom reads. These often involve mechanisms like gap locks or next key locks, which proactively lock the spaces between index entries. This prevents new rows from being inserted into those gaps that would satisfy the query's conditions. However, it is vital to remember that these advanced locking mechanisms are implementation details specific to certain database platforms and are not a universal guarantee inherent to the standard SQL definition of repeatable read. Understanding the specific locking mechanisms and guarantees of your chosen database system is absolutely paramount. While the standard SQL definition of repeatable read is quite clear about what it does prevent, its protection against phantom reads can indeed vary significantly depending on the underlying database engine. For critical operations where absolute consistency is paramount and the unexpected appearance of new data is simply unacceptable, escalating to the serializable isolation level is generally the safest and most portable approach. This ensures your transactions operate as if they are the only ones running, providing the highest level of isolation and data integrity, and giving you peace of mind that your data remains precisely as you expect it, every single time.
If this helps you code smarter, like, subscribe, and stay tuned for more.